Hello, everyone. I hope you've been enjoying the event so far. It's my absolute pleasure to welcome you to the next session, where we will deep dive into the fascinating world of API testing. We are privileged to have with us one of the foremost thought leaders in software testing, Michael Bolton. Michael's a consulting software tester, teacher, and co-creator of Rapid Software Testing, a methodology designed to tackle testing challenges expertly and credibly under uncertain conditions and extreme time pressure. With 30 years of experience in testing and development and management and writing about software, Michael has taught rapid software testing in 35 countries across 6 continents. He currently leads Develop Sense, a Toronto-based consultancy, and has worked with organizations ranging from startups to global corporations in banking, retail, telecoms, and much more. In this session, Michael will share insights from an intriguing exercise he undertook alongside James Bach, a journey that began with a simple exploration of an API, but quickly revealed surprising complexities. As Michael demonstrated, API testing is far more than verifying input and output relationships. It's an exploratory and investigative process that uncovers the richness beneath the surface. So with that, over to you, Michael.
Hi, David. How you doing?
I'm very good. I'm so excited for this session. I hopefully, with that intro, I've done you a great service in describing all that you have done. I'm really looking forward to this topic because generally I come from an automation space and development space, and I've always thought API testing can only be inputs and outputs, but I tend to look at it overly simplistically. So I'm really looking forward to this session.
Well, you're right that a lot of people do have that perspective. They have that take on what API testing is all about. I mean, what could be simpler than sending something to a server and waiting to get a reply back? And if the reply you get back is right, then everything's great. Well, what that description, although it's to some degree accurate, does is it covers up all the little things that we run into, all the learning that happens, all the obstacles that we bump into, and we don't talk about that. And I'm fascinated as to why we don't. And we'll offer some reasons for that maybe towards the end of the talk. So with that in mind, let's pop in to the secret life of testing and automation. This is a little exercise that we went through, James and I, with a friend of ours who wanted to learn more about API testing. So that was our mission. And to do that, we went here. We went to congress.gov and its API, api.congress.gov. And we looked about for something that, look, maybe not too hard to probe. Something simple for somebody who's learning how to program and who's learning how to interact with this stuff. So we looked at that. A simple get that returns a list of members of the U.S. Congress. Insert your own joke here. We'll tell you. All right. So anyway, here it's swaggerish kind of documentation. So there's an example request. That's kind of nice. There you go. Straightforward. Copy that. We went to get an API key. That's not hard to do. Look at that little typo there. How about we fix that? So we grabbed an API key and we used the example request that you see there. All we had to do was write a little call to call the members endpoint and return it as a JSON. And then we wrote a little assert to look for the string green in the output. Now, why that? Well, we know of a famous representative of that name. So our tacit knowledge, our awareness of things around us in the world that have not necessarily been expressed to anybody else. Anyway, we wrote an assert into the code to check for that value in the output, and then it returned false. Well, that doesn't make sense because we know she's a member of Congress. So we captured the output to a file, and we scroll back through the screen, and when we looked, green wasn't there. Plus, it seemed that what we were getting wasn't that long. Well, maybe it'd be good to show you. We had to do some sense making of what we were seeing. So when we did, I'll show you a little bit of this going on in a sec. When we looked more closely, we looked at the call first, but we hadn't looked at this part. There was an option higher up on this particular screen that would allow us to choose XML or JSON. So the answer came back like that. But we had ignored the offset and the limit. We'd forgotten about that. We didn't really know about this. Oh, and there's also these other fields. We sort of chose to not pay attention to those for the moment. They're optional. Oh, and there's a current member string as well for true or false. Okay. All right. So once we noticed that and we set it to true and we did the call again, we got green in the first batch of 250 records. Insert your own joke about the test running green at that point. And then we thought, well, wait, there's more people than that in the US Congress. There's 100 senators. There's some number of representatives. I think that I wanted to say 438 because this name 538 stuck in my mind. So we were just walking our friend through the process of writing code to do this stuff. So we said, all right, well, let's do this the easy way. We won't write any looping yet or any logic to figure out if we got to the end. Let's just do it the easy way. Call the function 3 times, first with an offset of 0, and second with an offset of 250, and then third with an offset of 500. And that should give us all the records from the current members set. And then we wanted to use a product called JQ. Now, JQ is a tool, very interesting tool that allows you to probe and walk through JSON. So let's have a look at what happened, because the first thing we did with JQ, it bombed. And that's when we looked at the file itself, that error message seemed to be because this isn't a valid JSON. Now, what's going on with that? These two characters here, if it's a JSON, they shouldn't be there. They shouldn't be there, whatever they are. And we didn't know what they were. So we had to do some sense making on that. So it took us a little while to figure this out. When we looked at the output file in a text editor, we noticed that the file encoding was UTF-16. Now, I don't know why, but stuff that's coming down off the web should be in UTF-8. So we did all kinds of things in our source code to try to turn the output into UTF-8. James had had some more experience with this and realized that this is a hazard sometimes, and something that receives code in one kind of encoding doesn't get it back in the other. So anyway, we tried to do all that. And then in that terminal window, this one right here, the set command, which and a bunch of my batch commands, they weren't working as usual. So this was weird. Just one of those daily little obstacles that nobody really talks about, nobody mentions. Time for some more sense making. So we looked around in the IDE, and what we found out was this. I suddenly noticed this. This is not my normal prompt. At the command line window, this is a PowerShell prompt. And it turns out that the IDE had changed my shell to PowerShell without me noticing. This sort of stuff happens all the time. And David, I see you nodding. This
Definitely.
sort of stuff happens all the time. These little obstacles and irritations, surprises that we bump into, that we stumble into. All right, so what happened next? The shell in the PyCharm terminal window had changed to PowerShell without my noticing, and that affected the encoding. Maybe that was the deal. And sure enough, changing to cmd.exe, the normal Windows command prompt, made that problem go away. And so now we could use our text editor and JQ for some data analysis. So we got started with that. Now, JQ is something that allows you to think of it as a grep specially designed not only for JSONs, but for JSON structures. So let me show you a little bit about how that goes. Let's give you an example here. I'll put that on the screen. And what is let's look at the first command there. First command is to take the file and just run it straight through JQ, and JQ's job is to pretty print it and then spit it back out. So that's what it does. There you go. Something on the order of 500 members of Congress or so. It takes a little while to do that. I think to get through the whole list and have it scroll past on the screen isn't that exciting, but you can sort of see things as it goes by. You can see little bits and pieces of stuff. Oh, look, there's a name and a party name. And if this were a command window rather than a recording, we could scroll up. But one of the things JQ allows you to do is to see the keys at each level. So the top level keys in this file, cong.json, which is the output from the query we made. If we look on members, that is an array with, it looks like 550, that is 549 plus 1 for the 0th. Let's look at what's in the first one, members 0. And look, there's some more keys under that. The BioGuide ID, depiction, district, name, party name, state, terms, and so on and so forth. All right, well, let's look what's under name. Oh, I missed a step there. Let's go back. One of the things you can do, let's go back, is if you put a 0 in here, right there, that 0, if you put a 0 and add name to it, it will give you the value at that key value pair, that name. If you leave out an index number, it will iterate over all of them. And that's what we're seeing here. Hit the enter key, boom, there we go. 500 or so, 550, in fact, names of Congress people. Yep, 550 of them, because it will tell you the length of that array when you split it out as an array. Okay, that's pretty cool. How many of those are unique? There's a unique list. Let's see how long that list is by adding the length parameter to it, like that. There we go. And what is it? Oh dear, I went back to the beginning. Let's scroll out to the end there. There we go. If we add the length parameter and wait for the return value, 549. So there must be a duplicate name in there. Well, that's interesting. That's interesting, because here's the deal. Ladies and gentlemen, API testing is not just about the function. Does it return something? API testing, we're not function testers. We are system testers, and the system includes the data. So one of the things that JQ allows us to do is to probe at the data in very convenient kinds of ways. You could use a text editor for it, but sometimes the amount of stuff that you're looking at is big enough that it swamps the text editor, and the text editor just gives you one damn line after another. With JQ, you can do other stuff like that. So there should only be 538 members of Congress. I know that because this number 538 is sticking in my mind. So I thought, well, wait a minute. What if we looked for Santos? George Santos is we knew he was not, at the time we did this, was August 2024. We knew that he was not a member of Congress anymore. He wasn't in the Congress because he'd been doing bad things, naughty things. And so he got chucked out. So we knew he wasn't a member of Congress. And so we looked for him in the output. We took that last command that you saw and we piped it to a file. And look, there he is. So what's going on with that? Well, there's something also, when we looked a little further, there was something that did indeed seem like a duplicate. Robert Menendez. And we knew that he wasn't a senator either, because he had to resign in disgrace. A lot of nefarious stuff happening in the US Congress. So we looked, and sure enough, there was Robert Menendez. He's in there twice. Ha! Duplication in the data. Except, if you look even more carefully, you see that this one is in the House and this one is in the Senate. So it turns out, to our astonishment, there's two Robert Menendezes. Who knew? Who knew? So what we had there was an instance of an oracle that we had in our head being fallible. How did we not know that? We knew that because of a lack of relevant tacit knowledge, stuff that was not in our head yet, but that needed to be. But how would we have known that without performing some experimentation, without investigating and playing with the data? Oh, now we did find a problem, because when we clicked on the senator's bio, when we fed the senator's bio into a browser, it returned a 404. So we still had to figure out the differences between what the API had returned and what was purportedly a list of the current members of Congress. For example, what's her name? Dianne Feinstein had just recently died. And we knew that, again, because of just basic knowledge and awareness of living in North America. I'm a Canadian, but we get a lot of news from the South. So let's look at that some more. So at least some of the senators or Congress people had resigned. At least one was dead. We knew this. And the documentation didn't help us trying to sort this out, because that's all the documentation tells us that the responses are going to contain. It doesn't give us an instance of the structure. It gives us an example of the structure, but it doesn't tell us about what's supposed to be there and what might not be there. It doesn't tell us anything about intentions.
Sorry, Michael, for the intentions part, and hopefully you're going to get to it. Why don't developers tend to put that information there? Like, what is your experience on, like, why was that data missing in the first place, or the kind of the documentation?
My friend Keith Klain has a really nice aphorism. He says, "Show me the incentives and I'll show you the behavior." In the business of software development, what do we anticipate is going to be the result of it? Developed software. But there's a problem with that. And the problem with that is that the developers are very strongly incentivized to produce the code. They're very strongly incentivized to produce code. And that there's nothing wrong with that. I want to make that clear. That's what developers do. They write code. But they're sometimes not incentivized to do so much, is to write code that really works. Code that fulfills the requirements of everybody who is important, and that fulfills all of the requirements of everybody who's important. So there is a bias, a really strong bias put into the way we train and incentivize developers that circles around the idea of code being functionally correct.
Okay.
I mean, code should be correct, right? It better be correct. Because if the code isn't correct, some function is not going to get met. or some requirement rather, right? If the code is not functionally correct, the functions are what makes things happen in the product. Anything that
Right.
changes or happens on a computer, on a display, happens or changes because there's a function that makes that happen. So if the function is not right, the good thing won't happen. But there's an asymmetry here. Just because we have a collection of correctly operating functions, it doesn't mean that the requirements are going to get met. So there's this thing that people talk about in both development and testing that really bugs me: non-functional requirements. Well, there's another word I have for non-functional requirements: requirements. Right? That's what they are. When somebody says I got a requirement for something, nobody says, well, is that a functional requirement or is it a non-functional requirement? Nobody says that. My software, to satisfy me, it needs to be reasonably performant, it needs to be capable, it needs to be usable, it needs to be secure, it needs to be installable, uninstallable, configurable. All those things are requirements. To dismiss them or to even make the psychological move of calling them non-something, non-functional requirements, I think leads to a lot of dysfunction.
Yeah.
So, meanwhile, developers do not have particularly powerful incentives to write documentation because what's their primary deliverable? The deliverable is the code. So that's one thing. Another reason why developers might not produce this, it might not be their job to do it. It might be the job of a technical writer to do it. But of course, they fired all the technical writers even before they started firing testers. But here's the issue. The developer already has a mental model of the product. And when you are in the business of developing something or making something, that mental model travels with you. It's not that easy to get yourself outside of the space where you are and put yourself into the space of what would somebody who knows very little or nothing about this particular function or this feature, this API, this endpoint, what would somebody need to know? What might hiccup them? What might cause them trouble? I know that stuff already as the developer. I'm already immersed in that world. That's in my head already. So it's difficult for me to get critical distance away from that and to describe something from the perspective of somebody who's never seen it before. That's the issue there, I think. And as testers, we're in a really great position to point that out. But a lot of the time, what happens is we stumble into some kind of problem with the API, we go to the developer, we get our answer back, and yet that doesn't make it into the Swagger documentation or into the document, the other documentation for the API. That's what I think is happening there. Great question. Thank you for asking. Another thing that the documentation doesn't tell us about, there's a pagination field inside the JSON that comes back from the call, and it basically suggests the next call that you might want to make. Now, this is a common thing for developers, but for other people who aren't necessarily familiar with that API, it might be nice to highlight it and to say that it's available. So now it turns out that there's another mistake that I was making in my head because I was really confident about 538 as being the number of members of Congress. And the reason I made that mistake was because I was thinking of the famous website 538.com. 538.com. I think it's the one. Anyway, it's the one that everybody was looking at as a sort of aggregation of polling data. The 538 part refers not to the number of members of Congress, but it refers to the number of electors in the Electoral College. And I'd forgotten about that. I'd also forgotten that there are representatives for some of the U.S. protectorates, the Virgin Islands and Guam and places like that. And JQ is able to actually help us with that. Let's look at that a little bit. When you return the keys for members, note that there's party name and state and so on. So let's look and see what states are available. So the one for member number 0 is New Jersey. That's, I guess, Bill Pascrell there. So let's iterate through all of them and see what we get. Whoa, that's a whole bunch of them. I guess there's 550 altogether. So let's look for the unique ones. Now here I want to show you something. I want to show you a mistake. What happened there? I made an error. I forgot to close the quote. We bang into this sort of stuff all the time too, as we're doing stuff. Just like developers do, we make little mistakes, and that becomes a part of the time that it takes us to do stuff. We make errors. Everybody makes errors, but we don't talk about them. What I'm not showing you here is a whole bunch of the stumbling and a whole bunch of the extra mistakes that I made along the way. Anyway, here we go. Let's fix that up, and let's get a count of the unique states. I got it wrong again. Dang it. Let's go unique. Let's just look for the unique ones. Let's get our list, make sure we got that right. Okay. So if we pause there, we see that indeed there are things scanning down really quickly. Ooh, Northern Mariana Islands, Puerto Rico, Virgin Islands. We know, I know, I have an American passport. I was born in the United States to Canadian parents, that those things are not states. So how many of those are there? Well, let's clear the screen. And, oh, I went back to the beginning again. And let's scroll forward a little bit. And there's the length. There's 56 different constituencies from which senators or Congress people might come. Now, here's another thing we can do. We can take the output from JQ and we can pipe it through more. And so we can take the unique ones, and then there they are. And now we can look at them and ponder them and soak them up and learn something. District of Columbia, American Samoa, Guam, and then all the other things on there are states, so it seems. And then scroll down, and there's the rest of them. The ones I mentioned before, Puerto Rico and Virgin Islands, Northern Marianas Islands. Okay. This is once again going through the data and sort of savoring what we're seeing and creating and rebuilding and reassembling and correcting our models of things. So testing isn't just about writing automated checks. Before we can write checks well, we have to learn the product. And we have to learn the documentation, and we have to learn the tools and how to wrestle with them and argue with them and figure out, notice when they're not working the way we wanted them to. We also have to deal with the data and how to wrangle the data and analyze the data. We also have to develop oracles by which we would recognize problems. Now, we found some problems. We found ambiguity in the documentation. We found problems with the data under the data, that broken link that I referred to before. But now I've got a much better set of ideas on how I might test some of the data that's coming back from congress.gov. Now, for example, I can get a collection of all of the things associated with the images associated with each one of those Congress people. I can go to their bio guides. I can use, after I explore the other endpoints that are available in congress.gov, I can use those to check things against each other. So with what we learned, this all took us about a couple of hours to walk through and explain things to each other and so on. You're seeing this whole thing just compressed down to about 10 or 15 minutes. But we don't talk about those processes. Now, why might there be secret processes? A lot of the time there's secret processes, I would say, because people don't necessarily notice their own process. People don't know how to describe the processes that they're going through. if I describe something to you, many of the people who are watching this are going to be unfamiliar with JQ. They may even be unfamiliar with JSON. So when I describe what I'm up to, they might still don't get it. I could record everything that was going on as I was working, but that would feel like I was being under surveillance all the time. A lot of the time, people don't really care about the details. They just want the results. Another thing that could happen is I might be taking notes, trying to take notes. But James and I have noticed this all the time when we're testing together. I very often take on the role of note taker. But when we're on the chase, when we're on the hunt, when we see something interesting, all of a sudden the pencils go down and we start tying up our shoes and running after the problem or the thing that we're seeing, and we forget to take notes. If you saw, I would be embarrassed a lot of the time to show people my code because I don't code every day myself. James does, and his stuff is a lot better. But even he would experience some kind of nervousness and trepidation about showing people stuff. We want to polish it up before we show it to the outside world. Sometimes there's a lot of testing and a lot of checking that goes on that isn't really very valuable, and people might be nervous about copying to that. Sometimes the process is secret because people aren't looking into the code that they're responsible for running and maintaining. I got a question for you, David.
Yeah.
Supposing, just for fun, that we have a suite of, let's say 50,000 automated checks that we run on every build.
Okay.
All right. 50,000 automated checks. All right. If we reviewed those checks once a year, say, every one of those checks, we want to make sure we reviewed them once a year. How many checks would we have to review per day?
So the interesting thing here is I have slightly different phrasing for this. So just for clarification, because to me a check and a test is the same thing, but an assertion could be different to the check here. So are we talking about checks versus checks being an equivalent to a test in this case? I just want to double check before I give my answer.
Okay, well, I love the way you've avoided a trap here. And I'm not even sure what the trap might be. And we're going to sort that out in the process of discussing this. But what you've done is really super, super important. And that is you've asked, hey, what are you actually talking about? Because let me give you one part of the answer at least. A check is not a test. A check cannot be a test because, at least in our parlance, because a check is the operation of the product and collection of data about it, and the application of a decision rule, which can be done, at least in theory, by a machine, algorithmically.
Yeah.
So a check is not a test, and here's why. Because for something to be a test, we have to have the intention to investigate a risk. We have to express that intention in terms of a question that can be encoded into a yes or no binary true or false assertion. I like the way you use assertion there. Then, for it to be a test, we can't just see a red light go on at the end and say, oh, we found a bug. Because for it to be a test, we've got to make sense of it. We've got to evaluate what we're seeing. We've got to look at the possibility that maybe there's a bug in the check, or maybe there's a bug in the product, or maybe there's a misunderstanding or a disagreement between the environment that the check is running on and the environment that the product is going to be running on. Or maybe there's some kind of intermittent problem somewhere in there that's not related to either the check or the product code. So a check and a test cannot be equivalent. A test might consist of dozens of checks, hundreds of checks, which all get aggregated and interpreted and so on and so forth. But let's just say, even for the sake of argument, that there are 50,000 assertions, and maybe they're wrapped up into 2,000 automated, a suite of 2,000 automated so-called tests.
Yeah.
How many? The point's the same. How many assertions would we have to review every day?
I guess my next question would be like, how often are these making a difference, right? So it comes down to the reason why I'm asking this question. I've recently done a number of talks on flakiness in test suites, and generally that is down to what was down on your last slide, right? The secret processes, inherent knowledge or tacit knowledge that people have, or tribal knowledge, depending on like which groups you speak to, like how they describe it. But this knowledge that is really kept in, and it's then like for those, it's like, do we need to change those tools, check those things if they seem to be doing the right thing? Obviously, there is a point where, like, if you have too many red, you would want to turn them down, or kind of, if they're because I've spent a lot of my career at Mozilla, we called them oranges. Those are the flaky tests. You would do something else. And then for the green ones, for the most part, you would see how often they fail. And then, but it's all data driven, because I'm an engineer. I like to have the data where I can with these things, and then make a decision based on that, because you don't want to review everything all at once a year, because I don't think that is valuable. But
really,
yeah.
Okay, what percentage of your checks run red when they should actually be running green?
I think if anything is above 1% red, that is a huge problem. But it all depends on your test suite. So if you have a small test suite, everything should be green. If you have a huge test suite, you could probably get away with 1% being red, but it all depends on the flakiness amount of data coming in. Again,
okay,
track the data on it.
Out of 50,000 automated checks, 1% of them are running red. Falsely.
Yeah.
Right? And now, so how many is that? Some. I've got a question, though. How many of them are running green when they should be running red?
So that is a really good question, and that without, this is where I always encourage people to do test-driven development, because I'd never trust a test that I've never seen fail.
Well, but on the by the same token, what if a check that is running green in a way that it should not? How are you going to find out about that? The way you're going to find out about it is review.
Yeah, but as you've pointed out quite clearly with my last question, is that it's the incentives. Is there an incentive to do that?
Right. So here's what I think is really problematic with all that, and that is, on the assumption that 1% of your red checks are running red inappropriately, what's the possibility that 1% of your green checks are running green inappropriately? That's 500 out of 50,000. That's a lot of checks running green that aren't finding problems that maybe should be finding problems. But the point is, we won't know unless we review, unless we look into it. So let's return to that. I thought that might be an interesting little diversion there for a moment. Of course, one of the reasons we don't do that review is because problem after problem keeps cropping up, and I can't predict when they're going to end. We don't talk about our processes because every situation is unique. It's hard to generalize about how we investigate stuff and the problems we run into. Sometimes we can't even tell how this stuff works. And we're not incentivized to learn that necessarily. So I wanted to show you just that little list of stuff there so that we can look at this. Now, we got a diagram that shows why there might be secret processes. And I hope this is large enough to see. There are processes, how things happen. There's knowledge of those processes. There's data about those processes. There's the nature of those processes altogether, the sort of overarching paradigms associated with them. And then there are people's relationships within the social business of developing software that are considerations too, and we're trying to explain and describe our processes and so on. So one of the things I've noticed is that testers often have a hard time explaining what they do. Anybody who is immersed in a craft, at least potentially, unless they've done a lot of introspection and analysis of what they do, they may have a hard time describing it because they just do it. It's natural to them, and they don't really think about it in the same way that parrots don't describe how they fly. They already know how to fly, and they don't. Obviously, parrots don't explain things, but of course, neither do stochastic parrots, LLMs. So descriptions of the testing process are all often incomplete or mistaken. Recording data about testing is kind of like the developers not documenting their stuff. It takes time, it takes discipline, it takes trust, it takes incentives. The nature of the process are not necessarily hard to describe, but they're mental things. They're not legible and they're not visible. And sometimes people don't see value in explaining their process to people outside of that process. So those are the issues associated with that. So processes in testing an API are often secret because of the incentives, because of the problem of not taking the time to make systematic observation of what you're doing. Those stumbles and problems might be hard or inconvenient or expensive to record. Some of the recordings may be done in error. Going over this talk, I realized that I misrepresented at least two things that didn't work exactly the way I described them. It's hard to study this kind of work. It's hard to describe it. And the people who tell the story and the people who are hearing the story may not be that well connected. And sometimes some of what we do is considered either not a big deal or something that is kind of embarrassing. So it's hard to come forward. Anyway, that's my story on the testing of an API and some of the secret work that might go along with it, and why that work might be secret.
Brilliant. I really loved that, and it was I found it very insightful. It's given me fruit for thought on a number of things, because I'm a big advocate of people getting things wrong with software by not understanding the underlying data structures, software, things like that. As I said earlier, recently did a talk on flaky tests, and a lot of the reason why we have flaky automation tests or automated checks, however we want to describe them, is because the way we think through how software works and how our brain and how software actually works in reality are normally two very different things.
Yeah. I mean, they say it's easy, but the stuff that we end up doing turns out to be hard.
Yeah.
And they don't believe it's hard because, among other things, the tool vendors told them that it was easy.
Yeah.
And therefore, if I mean, the guy told them on the golf course that this stuff is easy to do, that's what the tool vendor told the CTO. And so, therefore, we're going to keep a lot of the problems secret and quiet. And the boss is going to say that it looks easy.
Yeah.
So that's the vision you got right there. And the reality is something a bit more like this.
I love that. Absolutely love that. Brilliant. So thank you very much for that, Michael. We really appreciate the time that you took with us today, sharing that. I found it very insightful. I enjoyed the conversations. It's given me a lot of food for thought, as I said, that I'm going to go away, and there's a few blog posts where it's like, oh, I remember that thing. I'm going to go write about and share my points of view, especially coming from a different side of testing from you. But as I kind of regularly tell people, Marit has a fantastic phrase where she describes test automation and exploratory testing and everything in between just being part of a great big cycle of quality and improving quality. There's not one side that ever should be better than the other, because together we improve everything. And so I've got some good ideas that I want to go talk about now, because this has just inspired me. Thank you.
Well, thank you. I want to be careful about one thing, though, and that is testing doesn't improve quality. Testing doesn't improve quality. Testing tells us where quality might need to be improved, but testing doesn't improve quality. Just in the same way that weighing yourself doesn't make you healthier. But testing, weighing yourself finds out ways in which you might want to be healthier by, say, for instance, losing some weight. So I want to be really careful about that, because if we do a fabulous job testing, the product still might not get better.
No, that is true. It gives us insights and data on what we should be doing next.
There you go. There you
Brilliant.
go.
Thank you for that. And I hope everyone enjoys our next session.
Thank you, David.
Thank you.